Download this code from codegive.com, link in the description below. Comprehensive Guide to Error Handling in SQL Server Stored Procedures. Error handling is a crucial aspect of writing robust and reliable stored procedures in SQL Server. Properly implemented error handling ensures that your procedures can gracefully recover from unexpected situations, prevent data corruption, and provide informative feedback to users or calling applications. This tutorial will cover various techniques, best practices, and code examples for effectively handling errors in your SQL Server stored procedures. 1. Understanding the basics of error handling in SQL Server. Before diving into code, it's essential to understand the core concepts. Error numbers and messages. SQL Server assigns unique error numbers to various issues, example divide by zero, constraint violation, syntax errors. The error_number function retrieves this number. Error_message returns a human-readable description of the error. Error severity and state severity indicates the impact of the error. Severity levels 0 to 10 are informational messages. Severity levels 11 to 16 are correctable errors, and 17 to 25 indicate severe errors that may require system administrator intervention. State provides additional context about the error. Different states for the same error number can represent different scenarios. Try, catch blocks. The cornerstone of structured error handling in SQL Server. Code that might raise an error is placed within a try block. If an error occurs, execution immediately jumps to the corresponding catch block. At error global variable an older approach to error handling. After each T-SQL statement, at error holds the error number generated by that statement. A value of 0 indicates success, a non-zero value indicates an error. While still functional, it's less reliable and more verbose than try, catch. Raise error statement allows you to explicitly raise errors, either with predefined error messages or custom messages. This is vital for signaling problems within your procedure logic or re-raising errors captured in a catch block. *XACT_state, function crucial for transactional integrity. It returns an integer representing the state of the current transaction. *0, no active transaction. *1, an active transaction that can still be committed. *1, an active transaction that is uncommittable. This means an error occurred that corrupted the transaction, and the only safe operation is to roll back the transaction. 2. Implementing try, catch blocks. The try, catch block is the preferred mechanism for handling errors in modern SQL Server code. Here's the basic structure. Explanation begin try starts the try block. End try ends the try block. Begin catch starts the catch block. The catch block is executed if an error occurs within the try block. End catch ends the catch block. Inside the catch block error_number, error_severity, error_state, error_procedure, error_line, error_message. These functions provide valuable information about the error that occurred. The error_procedure function tells you the name of the stored procedure where the error occurred, if it occurred in a stored procedure. Error_line tells you the line number within the procedure. Transaction handling if at tran count 0 rollback transaction is critically important if your try block contains any data modification statements, insert, update, delete. If an error occurs after some changes have been made, you must roll back the transaction to ensure data consistency. @tran count checks the number of open transactions. Error re-raising or error code return. You can either re-raise the error using RICE error, typically with a severity level between 11 and 20. This allows the calling application to handle the error. You can also customize the message. Return a custom error code, example return -1. This allows the calling application to check the return value and handle the error accordingly. This is often used for simpler error scenarios. 3. Detailed examples of error handling in stored procedures. Let's look at several practical examples. Example 1, Basic Try, Catch with transaction handling and error logging. Key improvements in this example: set no count on, suppresses the n-row, affected messages, reducing network traffic. Input validation, the procedure validates the input parameters, at price and at category ID, before attempting to insert the data. This prevents common errors like inserting invalid data. Using RICE error for input validation is a good practice. Transaction handling, the code uses begin transaction and commit transaction to ensure that the insert operation is atomic. If any error occurs, the entire transaction is rolled back, preventing partial updates. Error logging, the catch block logs the error details, error number, severity, state, procedure, line, message, and timestamp, to an error log table. This is invaluable for debugging and identifying recurring issues. You can also use SQL Server error log. Re-raising the error, the RICE error statement re-raises the error to the calling application, providing a generic error message. The application can then handle the error appropriately, example display an error message to the user. You re-raise the error after logging it to ensure that the error is recorded even if the application doesn't handle it. Error number, raise error allows you to specify the error number, severity, and state, helping you to maintain consistency in the error handling mechanism. Example 2, using XACT_state, for more robust transaction management. Explanation of XACT_state, XACT_state, equals -1 This is the most important check. It indicates that the transaction is in an uncommittable state. This often happens when a constraint violation occurs, example trying to insert a duplicate key or violating a foreign key relationship. In this case, you must roll back the transaction. Trying to commit a transaction in this state will result in another error. XACT_state, equals 1 The transaction is still active and can be committed. This means that the error was likely a logical error, example a RICE error or some other condition that didn't directly corrupt the transaction. However, even in this case, it's best practice to roll back the transaction to maintain data consistency and avoid unexpected side effects. XACT_state, equals 0 There is no active transaction. This is unusual inside a catch block if you started a transaction in the try block. If XACT_state is 0, it means either the transaction was committed successfully before the error or something went wrong with the transaction initiation itself. You shouldn't attempt to roll back in this state. Why is XACT_state important? Using XACT_state makes your error handling more robust. @tran count 0 rollback transaction might work in many cases, but it doesn't guarantee correctness in all scenarios. If an error occurs that puts the transaction into an uncommittable state, @tran count might still be greater than 0, and a simple rollback might not be sufficient. XACT_state provides a more reliable way to determine the true state of the transaction. Example 3, nested try, catch blocks. You can nest try, catch blocks to handle errors at different levels of granularity. This is useful when you have complex logic where you want to handle specific errors locally and re-raise others to a higher level. In this example, if the inner procedure encounters an error, the catch block in inner procedure will be executed. If the rice error in inner procedure were uncommented, it would re-raise the error, causing the catch block in outer procedure to be executed instead of the outer procedure catch. If the rice error is commented out, the inner catch handles the error and continues to the outer procedure. Important considerations for nested try, catch asterisk. Asterisk error bubbling asterisk errors bubble up through the call stack until they are caught. If an error is not caught in a procedure, it will be propagated to the calling procedure, if any. Asterisk rice error control asterisk the rice error statement is key to controlling how errors are propagated in nested blocks. If you re-raise an error, the current catch block ends, and the error is passed up the call stack. If you don't re-raise, the current catch block handles the error, and execution continues in the try block after the catch block. 4. Using at error, legacy approach. While try, catch is preferred, it's helpful to understand the older at error approach, especially when working with legacy code. Disadvantages of at error asterisk. Asterisk less reliable asterisk at error is overwritten after each statement. You must check it immediately after each statement that might fail. If you have multiple statements between a potential error and the check, at error might contain a misleading value. Asterisk verbose asterisk you need to check at error after every statement, making the code more verbose and harder to read. Asterisk no structured error information asterisk at error only provides the error number. You don't get access to severity, state, procedure name, or line number unless you use other, even more cumbersome techniques. Asterisk no transaction management asterisk at error does not automatically handle transaction rollback. You must manually manage transactions when using at error. Why try, catch is superior asterisk. Asterisk structured asterisk try, catch provides a clear and structured way to handle errors. Asterisk automatic transaction rollback asterisk with proper use of XACT_state, try, catch makes transaction management much easier and less error prone. Asterisk comprehensive error information asterisk the error underscore asterisk, functions provide detailed information about the error. Asterisk cleaner code asterisk try, catch makes the code more readable and maintainable. 5. Best practices for error handling in stored procedures. Asterisk always use try, catch asterisk for new code, always use try, catch for error handling. Asterisk validate input parameters asterisk check input parameters for validity before performing any operations. This prevents many common errors and improves security. Use rice error to signal invalid input. Asterisk handle transactions correctly asterisk use begin transaction, commit transaction, and roll back transaction to ensure data consistency. Always use XACT_state in your catch blocks to determine the transaction state and roll back appropriately. Asterisk log errors asterisk log error details to a table, or use SQL Server error log, for debugging and analysis. Asterisk provide informative error messages asterisk use rice error to provide meaningful error messages to the calling application or user. Avoid generic error messages that don't provide enough information to diagnose the problem. Asterisk avoid catch-all blocks asterisk while it's tempting to have a single catch block for everything, it's often better to use nested try, catch blocks to handle specific error types differently. Consider custom error codes. For simpler error scenarios, consider returning custom error codes from your stored procedures, example return-1, return-2. This allows the calling application to easily check for errors. If you're returning custom error codes, document what each error code represents. Don't suppress errors silently. Never suppress errors without logging them or taking appropriate action. Suppressing errors can lead to data corruption and make it difficult to debug problems. Use error handling to improve performance. Instead of checking for conditions with multiple if statements that consume resources, let the try, catch block capture the errors. However, prioritize input validation for the most common and easily preventable errors. Test your error handling. Thoroughly test your error handling by deliberately introducing errors, example dividing by 0, violating constraints, and verifying that your stored procedures handle them correctly. 6. Custom error numbers and messages, advanced. You can define your own custom error numbers and messages using sp_message. This allows you to create more specific and consistent error handling throughout your database. Explanation **** sp_message *** @misnum, a unique error number, typically in the range 50,000 to 99,999 for custom errors. *@* severity, the severity level, 16 is a common choice for application errors. *@* text, the error message. You can use placeholders like %s, %d, etc., to insert values into the message, as shown in the example. *lang, the language of the message. *with_log, specifies whether to log the error to the SQL Server error log. It's good practice to log custom errors. *rice error, 50001, 16, 1, add product name, when you raise a custom error, you provide the error number and any parameters to be substituted into the message. *error logging, when logging custom errors, the error_message function will return the custom error message you defined with sp_message. *re-raising, when re-raising the error, use rice error, error_number, error_severity, error_state, to preserve the original error information. Benefits of custom error messages. Consistency. Ensures consistent error messages across your database. Clarity. Allows you to create more specific and informative error messages. Localization. You can create localized versions of your error messages for different languages. Centralized management. Custom error messages are stored in the sys.messages system view, making them easier to manage. In summary, effective error handling is critical for creating robust and maintainable stored procedures. By using try, catch blocks, managing transactions correctly, logging errors, and providing informative error messages, you can significantly improve the reliability and usability of your SQL Server applications. Remember to test your error handling thoroughly to ensure that it works as expected in all scenarios. The use of custom error messages enhances the clarity and consistency of error reporting. The use of XACT_state is paramount in maintaining transaction integrity. Robust error handling in SQL Server stored procedures, a comprehensive guide. Error handling is a crucial aspect of developing robust and reliable SQL Server stored procedures. Without proper error handling, unexpected issues like data type mismatches, constraint violations, or resource limitations can cause your stored procedures to fail silently, leading to data corruption or application instability. This tutorial will walk you through various techniques for effective error handling in SQL Server, providing detailed explanations and practical code examples. Why error handling is important in stored procedures ***. Data integrity * prevents invalid or inconsistent data from being inserted or updated. Application stability * gracefully handles errors, preventing the entire application from crashing. Debugging and diagnostics * provides detailed error messages that help identify and resolve issues quickly. Transaction control * ensures that transactions are rolled back correctly when errors occur, maintaining data consistency. User experience * allows you to provide meaningful error messages to users, improving their experience. Techniques for error handling in SQL Server stored procedures **. SQL Server offers several mechanisms for handling errors within stored procedures. We will explore the following. 1. Error global variable, legacy the oldest and simplest method, but less flexible. 2. Try, catch block * the preferred and more powerful method for handling exceptions. 3. Throw statement * raises user-defined errors and allows for custom error messages. 4. Exact_state, function * checks the state of a transaction to determine if it needs to be rolled back. 5. Custom error tables * log errors to a dedicated table for monitoring and analysis. Let's delve into each technique with detailed explanations and code examples. 1. Error global variable, legacy approach. Description The error variable is a system-defined global variable that stores the error number of the last T-SQL statement executed. If the statement executes successfully, error is set to 0. Usage after each potentially error-prone statement, you check the value of error. If it's not 0, an error occurred, and you can take appropriate action, example log the error, roll back the transaction, and return an error code. Limitations single statement awareness error only captures the error from the immediately preceding statement. It doesn't persist across multiple statements. No exception handling it doesn't provide a mechanism to catch and handle exceptions in a structured way. You have to explicitly check error after each statement. Limited error information it only provides the error number. You need to look up the error message using system views or catalogs. Example Explanation One set no count on suppresses the X rows affected messages from being returned, which can improve performance. 2. Begin transaction starts an explicit transaction. 3. Insert into products executes the insert statement. 4. If error 0 begin. And checks if an error occurred after the insert statement. If error is not 0, it means an error occurred. 5. Rollback transaction rolls back the transaction to undo any changes. 6. Rice error message 16 1 raises an error message. Rice error is used to generate custom error messages. The first argument is the error message, the second is the severity level, 16 is generally considered an error, and the third is the state, a user-defined value that can help categorize errors. 7. Return-1 returns an error code to the calling application. This allows the application to know if the stored procedure executed successfully or failed. A return value of 0 is typically used to indicate success. 8. The same process is repeated for the update statement. 9. Commit transaction if no errors occurred, the transaction is committed, making the changes permanent. Important considerations for at error asterisk. Asterisk resetting at error asterisk at error is reset to 0 after each statement. If you need to check for an error, do it immediately after the statement that might have caused the error. Asterisk concurrency asterisk at error is global to the connection. In a high concurrency environment, it's possible for the value of at error to be overwritten by another process before you can check it. This is a major drawback. Asterisk use with caution asterisk while understanding at error is helpful for maintaining older code bases, the try, catch block, discussed below, is the recommended approach for new development. 2. Try, catch block, recommended approach. Asterisk description asterisk the try, catch block provides structured exception handling, similar to try, catch blocks in other programming languages. Code within the try block is monitored for errors. If an error occurs, the execution immediately jumps to the catch block. Asterisk usage asterisk you enclose the code that might raise an exception within the try block. The catch block contains the code to handle the error, example log the error, roll back the transaction, and return an error code. Asterisk advantages asterisk. Asterisk structured exception handling asterisk provides a clear and organized way to handle errors. Asterisk error information asterisk the catch block gives you access to detailed error information using functions like error underscore number, error underscore severity, error underscore state, error underscore procedure, error underscore line, and error underscore message. Asterisk transaction management asterisk makes it easier to manage transactions and ensure that they are rolled back correctly when errors occur. Asterisk more robust asterisk handles a wider range of errors than at error. Example asterisk. Explanation asterisk. 1. Begin try. And try asterisk asterisk encloses the code that might raise an exception. 2. Begin transaction, asterisk starts an explicit transaction. 3. Insert into products, and update product counts, asterisk statements that perform database operations. 4. Commit transaction, asterisk commits the transaction if no errors occurred in the try block. 5. Begin catch. And catch asterisk asterisk the catch block is executed if an error occurs in the try block. 6. If at tran count 0 rollback transaction, asterisk this is crucial. It checks if a transaction is currently active, at tran count 0. If it is, the transaction is rolled back. This prevents partial updates from being committed in case of an error. 7. Error underscore message, error underscore severity, error underscore state, asterisk these functions retrieve detailed error information about the error that occurred. 8. Rice error, at error message, at error severity, at error state, asterisk this rethrows the error, propagating it to the calling application. Rethrowing is important because it allows the application to handle the error appropriately. If you don't rethrow, the application might not be aware that an error occurred. Using the original error message, severity, and state is generally recommended to preserve the context of the error. 9. Return-1, asterisk returns an error code to the calling application. Best practices for try, catch blocks asterisk. Asterisk wrap transactions asterisk always wrap any database operations that should be atomic, all or nothing, within a transaction and a try, catch block. Asterisk check at tran count before rolling back asterisk always check the value of at tran count before rolling back a transaction in the catch block to avoid errors if there isn't an active transaction. Asterisk rethrow errors asterisk rethrow the error using rice error in the catch block to propagate the error to the calling application. Use the error underscore asterisk functions to preserve the original error information. Asterisk log errors to a dedicated error table, see below, for monitoring and analysis. Asterisk keep try blocks small. Asterisk keep the code within the try block as concise as possible to improve performance and make debugging easier. Focus on wrapping only the code that is likely to throw an exception. 3. Throw statement, raising custom errors. Asterisk description. Asterisk the throw statement allows you to raise user-defined errors with custom error messages, severity levels, and states. This is useful for enforcing business rules and providing more informative error messages to the calling application. Asterisk usage. Asterisk you use the throw statement to explicitly raise an error when a specific condition is met. Asterisk syntax. Asterisk error underscore number, an integer between 50,000 and 214-748-3647, inclusive, that identifies the error. Error numbers below 50,000 are reserved for system errors. Asterisk message, a string containing the error message. Asterisk state, an integer between 0 and 255, inclusive, that provides additional information about the error. Example asterisk. Explanation asterisk. 1 if at new price equals 0 begin. Throw. End, asterisk validates the input at new price. If the price is less than or equal to 0, the throw statement is used to raise a custom error with error number 51,000, a custom message, and a state of 1. The return statement is critical to stop further execution within the try block after the throw statement. 2 if at row count equals 0 begin. Throw. End, asterisk checks if any rows were updated by the update statement. If no rows were updated, meaning the product ID is invalid, the throw statement raises another custom error with error number 51001. 3. The rest of the procedure is similar to the previous example, with a try, catch block to handle any exceptions that might occur. Key points about throw asterisk. Asterisk error number range. Asterisk use error numbers between 50,000 and 214-748-3647 for custom errors. Asterisk throw inside catch. Asterisk if you use throw, without any arguments within a catch block, it rethrows the original exception that was caught. This is equivalent to rethrowing with rice error and error underscore asterisk functions, but it's more concise. Asterisk return after throw, outside catch. When throw is used outside of a catch block, you must include a return statement immediately after the throw statement to prevent further execution within the stored procedure. Otherwise, the code after the throw will still be executed, potentially leading to unexpected behavior. Asterisk consider severity. Asterisk the throw statement does not accept a severity parameter. The default severity is 16. If you need a different severity, you should continue to use rice error. 4. XACT underscore state, function, transaction state verification. Asterisk description. Asterisk the XACT underscore state, function returns a value indicating the current state of a user transaction. This is especially useful in catch blocks to determine whether the transaction is in a committable or uncommittable state. Asterisk return values. Asterisk 0, there is no transaction in progress. Asterisk 1, the transaction is in progress and can be committed. Asterisk -1, the transaction is in an uncommittable state due to an error that has occurred. Asterisk usage. Asterisk you use XACT underscore state in the catch block to check if the transaction can be committed. If XACT underscore state returns -1, the transaction must be rolled back. If it returns 1, it can be committed, but it's generally safer to always roll back in the catch block to ensure consistency. Example asterisk. Explanation asterisk. 1 XACT underscore state, 0 asterisk checks if a transaction is active, XACT_state, is not 0. If so, it proceeds to roll back the transaction. 2 XACT_state, equals -1 checks if the transaction is in an uncommittable state. This typically happens when a severe error, such as a constraint violation or deadlock, occurs. 3 rollback transaction, rolls back the transaction. It's crucial to roll back the transaction to ensure data consistency. Why is XACT_state important? Some errors, like constraint violations or deadlocks, can put a transaction into an uncommittable state. If you try to commit a transaction that is in an uncommittable state, you will get an error. XACT_state allows you to detect this and take appropriate action, roll back. 5. Custom error tables, logging errors. Description create a dedicated table to store error information for monitoring and analysis. This provides a centralized location for tracking errors that occur in your stored procedures. Usage in the catch block of your stored procedures, insert error information into the error table. Example Explanation 1. Create table dbo.errorlog, creates the error table with columns to store error information. Crucially, it includes parameters XML to capture the input parameters to the stored procedure, which is incredibly helpful for debugging. 2. Declare @params XML, set @params equals, this section constructs an XML representation of the input parameters passed to the stored procedure. This XML data is then stored in the parameters column of the error log table. Using XML is a flexible way to store the parameters, regardless of their data types. 3. Insert into dbo.errorlog. Values, inserts a new row into the error log table with the error information obtained from the error_*, functions. 4. The error is rethrown using error and return -1 to indicate failure to the calling application. Benefits of using a custom error table centralized error tracking provides a single location for viewing and analyzing errors. Historical data stores error information over time, allowing you to identify trends and patterns. Detailed information captures comprehensive error details, including the error number, severity, state, procedure name, line number, and message. Parameter logging storing the parameters passed to the stored procedure when the error occurred can be invaluable for debugging. Complete example with all techniques combined This example combines all the techniques discussed above for comprehensive error handling. Summary Use try, catch blocks for structured exception handling. Wrap transactions within try, catch blocks to ensure data consistency. Check at tran count before rolling back transactions. Use throw to raise custom errors when business rules are violated. Use XACT_state, to check the transaction state before attempting to commit or roll back. Log errors to a dedicated error table for monitoring and analysis. Capture parameters passed into the SP in XML format for easy debugging. Rethrow errors in the catch block to propagate them to the calling application. By implementing these error handling techniques in your SQL Server stored procedures, you can significantly improve the reliability, maintainability, and robustness of your database applications. Remember to tailor your error handling strategy to the specific requirements of your application and the types of errors that are most likely to occur.